friends, now we are in the first class of root locus technique. Here we will see some previous year GATE problems and how to solve those problems. So let me summarize about root locus. What is root locus actually? Actually, root locus is the locus of roots of characteristic equation when k is varied. This is the k. So k is open loop gain k. So when k is varied from 0 to infinity. Suppose there are more than one variable. Suppose here there is k, there is more than one variable. Suppose there is alpha also somewhere in numerator or denominator. Then if alpha is also varied, so for different values of alpha we will get different root locus. Then those locus in whole are called root contours. But here we are not bothered about root contours because we are here only to solve root locus problems when k is varied. So let us see the first problem. What is the first problem? The first problem is the root locus of a unity feedback system is shown in figure. This is the figure shown. The closed loop transfer function of the system is. So this question has been asked in GATE 2014 S1. So there are 4 alternatives given. So let us see which option is correct. Before looking at the solution of this question, let us see whether this question is fully correct or not. So in the figure there are two poles are shown. There is no pole or zero except these two poles. So at first I would like to comment on this, that the branch of root locus which is shown right to -1, right to pole -1, the branch of root locus on real axis right to point -1 and the branch of root locus on real axis left to pole -2, both will not exist actually. Why both will not exist? Because the branch of real axis right to which the total number of poles and zeros are in odd number, that branch will be that branch of real axis will be only part of root locus. But here we can see right to this branch there is no the total number of poles and zeros are nothing. So since there are no pole and zero, so this branch will not exist. But it is shown that it is existing. Also here we can say right to this branch. This is a branch of root locus on real axis. Right to this branch, the total number of poles and zeros are since there are no zeros, so total number of poles and zeros are 2. So it is also an even number, and we know that those branch of real axis will be a part of root locus right to which total number of poles and zeros are in odd number. So this will also be not a branch of root locus, but it is given. The question is given like that. So assuming this data is correct, we should proceed to find out the solution. So what is given? The forward path transfer function is given. So it is given that the open loop poles are given. Okay, open loop poles, or you can say forward path poles are given. So it is given that GS into HS equal to the open loop transfer function, or you can say open loop transfer function is given that is GS into HS. That will be nothing but it will be K divided by S plus a pole is at 1 -1 and another pole is at -2. So S plus 1 into S plus 2. Since there is no zero, so nothing will come in numerator except open loop gain K. Now the closed loop transfer function Ts is given by, let me write closed loop transfer function as CLTF, and it is given by, this is equal to this, this will be nothing but Gs divided by 1 plus Gs into Hs. Okay, again it is given that this is a unity feedback system. Okay, if this is a unity feedback system, then we can say that Hs will be equal to, that will be equal to 1. So if this Hs is equal to 1, if this Hs is equal to 1, then the above open loop transfer function will be equal to nothing but this will be only equal to Gs. Okay, and this will be equal to Gs divided by 1 plus Gs. Now if we put the value of Gs here, then we can find the closed loop transfer function Ts. Let me denote it by Ts, capital Ts. Okay, so Ts will be nothing but Gs. Let me put the value of Gs, s plus 1 multiplied by s plus 2 divided by 1 plus k divided by s plus 1 into s plus 2. Okay, so now if we solve this, then k divided by s plus 1 into s plus 2, this will come in denominator, and s plus 1 into s plus 2 divided by k plus s plus 1 into s plus 2. Okay, now these two terms s plus 1 multiplied by s plus 2 will cut each other, will cancel each other. So k divided by, the final value will be the k divided by s plus 1 into s plus 2 plus 1. So which of the given options are correct? So option number D is correct one. Option number D is correct one. So this option is correct. The next problem is, figure shows that the root locus plot location of poles not given of a third order system whose open loop transfer function is this. There are 4 alternatives given, and this question has been asked in GATE 2005. So the root locus plot is given. The root locus figure shows the root locus plot location of poles not given. So the root locus plot is given, and it is given that the system is of third order. Okay, third order system. So if the system is of third order, then the characteristic equation, then the open loop characteristic equation also must be of third order. So since all are third order system, so let us see which one is correct. Again, one thing is obvious from this root locus, that two branches of root locus start from s equal to 0. That means there are two poles lying on origin at s equal to 0. So we can write the transfer function, open loop transfer function, as the open loop transfer function will be the open loop transfer function will be, that is, we can say OLTF, that will be k divided by s square, and there must be some one more term. Let us see. So which one of these alternatives contain k divided by s square? So these two alternatives contain k divided by s square. Here here the next term is s plus 1, and here the next term is s. So let us see which one is correct. So if suppose this is correct, then the other pole must lie on s equal to -1. Okay, and other pole will also terminate at will also go to infinity, because there is no 0, and that will go that will go to 0 along this line. Why I am saying this line? I will prove. I will tell that later on. And if this is correct, then the third pole must also must be at s equal to 0. The third pole also must be at s equal to 0, and the third pole should also go in this direction. This direction means at an angle theta equal to minus 180 degree. So let us see which one of the two options A and B is correct. So suppose so there is only difference between these two is in this case, in option number B, the third pole is lying on s equal to minus 1, and in option number A, the third pole is lying on s equal to 0. So suppose the third pole is lying on s equal to minus 1. Suppose let us take the case B. Let us take the case B is correct. So let us take case 1. Case 1. Let us take the transfer function. The OLTF is GS into HS equal to K divided by S in square into S plus 1. So since this OLTF, this open loop transfer function doesn't have any 0, so all the three poles will terminate at infinity, and they will terminate along some asymptote, and those asymptotes are given by the asymptotes are given by phi A equal to 180 multiplied by 2q plus 1 divided by n minus m, where q equal to 0, 1, 2 up to n minus m minus 1. Now let me elaborate what is n and what is m. So here n is the number of poles. Here n is number of open loop poles. Okay, and m is number of open loop zeros. So the OLTF has how many open loop poles? So this OLTF has 3 open loop poles. So n will be equal to 3, and how many open loop zeros? There is no zero. There is no open loop 0. So m will be 0. So now we can write that from here. Now we can write 180 degree multiplied by 2q plus 1 divided by 3 minus 0, and q will vary from 0, 1, 2, because this goes to n minus m minus 1. So n minus m is 3. So 3 minus 1 means 2. So it will go up to 2. Now this will be equal to, if we put the value of q as 0, 1, 2, if we put the value of q as 0, then it will come 60 degree. If we put the value of q as 1, then it will come 180 degree. Okay, and if we put the value of q as 2, then it will come 300 degree. So it is clear. So two asymptotes will be along, one will be along 60 degree. This is 60 degree because this is root 3 and this is 1. So tan inverse here. Let me write this angle. This angle is nothing but tan inverse root 3, and that is equal to 60 degree. Okay. So if this angle is 60 degree, then again this angle will be this angle is nothing but this angle is 300 degree, and this angle will be nothing but 300 degree. Because this angle is again 60 degree, because root locus is symmetrical about real axis. So if this angle is 60 degree, this angle will be again 60 degree, and the whole angle, if we make the if we turn out on a circle, then the total angle becomes 360 degree. So this angle will be 300 degree. Now it is clear that this angle is 300 degree. So we have got two of its angle, one is 60 degree and other is 300 degree. So now it is clear that next pole, which is at s equal to -1, will go on this line, will go along this line, means at phi a equal to 180 degree. And from where it will start? It is the question, from where it will start. So it will start from here itself. So there is one more thing. That if this is the case, then what is the centroid? So what is centroid? Let me elaborate centroid. Centroid is the intersection of asymptotes on real axis. So centroid is nothing but it is the point of intersection of all the asymptotes on real axis. So centroid is given by minus sigma a equal to sigma real part of poles minus sigma real part of zeros divided by n minus m, where n is again number of poles and m is again number of zeros. So what is the real part of poles? So two of its poles, since two of its poles are at 0, so real part of pole will be 0 plus 0, and one pole is at -1. So sigma real part of poles will be 0 plus 0 minus 1, and since there is no 0, so real part of 0 will be 0 divided by 3. So it will be -1 by 3. So centroid must start at this point. Here the point -1 by 3 must be here left of origin 0. So the asymptote must be along this line, and but again one thing is clear, that this pole is starting from here at s equal to 0, and again this pole is again starting from here, and asymptote says that the definition of asymptote is that the asymptote is a line along which at infinity, if we go infinite along asymptote, then the curve, whatever be the curve, here the curve is root locus, the distance between the curve and asymptote must tend to 0. But here it will be the distance between asymptote and what will be here asymptote. If we make it by greening, suppose green, so it will be asymptote. Asymptote will be parallel line, and distance between this distance will always be maintained. This distance will never reach to 0, whether we go to infinity or whether we be anywhere, because these two lines are parallel lines. And the definition of asymptote is that line along which any curve tends at infinite, but at infinite it will not tend to asymptote, but the distance will be maintained. So it is clear that the asymptote must not start from here. It should start from 0. It should start from 0, because if it will start from 0, then asymptote will be along the root locus, and there will be no distance in fact between asymptote and the root locus at initially and at infinite also. So asymptote must start from t equal to at s equal to 0. So asymptote must start, because if it will not start at s equal to 0, then the distance will be maintained. And the definition of asymptote itself says that there should be no distance if we tend to infinity. There should be no distance between the curve and asymptote if we go at infinity. So this cannot be the starting point of asymptote. So the starting point of asymptote must be the origin, and for that the third root, this must not be s plus 1. The third root must not be at s equal to minus 1. It should also be at s equal to 0, because if third root is at s equal to 0, then this point will also be then this quantity will also be 0, and the centroid will be at 0, and all three branches will start from 0, and all three centroid will meet at origin. So this option is not correct, because centroid is not starting. So which option is correct? So option number C, option number A will be correct, because in this case centroid will be at 0. So it clearly says that option number A is correct, because here if we calculate centroid in this case is if we calculate centroid taking case, suppose we take case 2. So if we take case 2, then centroid will be again centroid will be at 0, and the curve will be the asymptotes will start at s equal to 0 along first asymptote will be along this line at theta equal to 60 degree, second asymptote will be at theta equal to 180 degree, and third asymptote will be at theta equal to 300 degree. So option number A is correct. Okay. The next question is, which of the following figures represent valid root loci in S plane for positive k? Assume that the system has transfer function with real coefficients. Okay, and this question has been asked in GATE 1992. So this question has been asked in GATE 1992. So let us analyze which of the given options are correct. So at first, this cannot be a valid root locus. This cannot be a valid root locus. Why I am saying? Because root locus is always symmetrical about real axis, and this is not symmetrical about, this is the real axis, this is not symmetrical about real axis. Again, here there are two poles and one zero. So there should be two branches, and one branch must terminate along infinity. But here it is not showing where one branch is going. The direction is also not showing. In this picture, direction is also not shown. So this option will also be not correct. Let us see about this option. Again, it is shown that there are this is a branch of root locus. Okay, this is a branch of root locus because the arrow is pointing towards this zero. Okay, but this will not be a branch of root locus. Why I am saying like that? Because right to this branch, right to this part of real axis, there are only two poles. That is, the total number of zeros and poles are in even number. So this will not be a part of root locus. But in this figure it is shown this is a part of root locus. So this will also be not a correct option. So let us see about what about A. There are two poles, and this is a branch of root locus because right to this part of real axis there is only one, the total number of poles and zero is only one. So this is branch of root locus. Okay, again this will also be a branch of root locus, because right to this branch, the total number of poles and zero are 1, because there is only one zero. So this whole will be a branch of root locus. Again two branch, again here right to this, this part of this real axis. Let us check what about part of this real axis. So part of this real axis, right to which total number of poles and zeros are 1, 2, 3. So total number of poles and zeros are 3 in number. So this part will be a branch of root locus, which is given here. Again the branches are starting from poles, and the two branches are meeting at here and break away for one branch is breaking away to 0 at here, and another branch is breaking away this 0. So this is the valid root locus. So which one is correct? Option number A will be correct one. The next question is, a unity feedback system has an open loop transfer function of the form kgs equal to k multiplied by s plus a divided by s square into s plus b greater than a. Which of the following is correct? There are 4 alternatives given. I mean, there are 4 root plots are given, and this question has been asked in GATE 1991. So it is given that the system is a unity feedback system, has open loop transfer function. The open loop transfer function is also given, and that open loop transfer function is kgs equal to, the OLTF is OLTF, this is equal to kgs, and that kgs is equal to nothing but k s plus a s square into s plus b. So it is clear from this open loop transfer function that there is a 0 at s equal to minus a, and there are 3 poles. 2 poles are at s equal to 0 and 1 pole is at s equal to minus b. So let me write here open loop zeros. So there is only 1 0 at minus a. Open loop poles. So there are 3 poles, 2 poles at 0 0 and 1 pole is at minus b. So 1 pole is at minus b and 1 0 is at minus a. So which of the given options are correct? So in all of these 4, the poles are at minus b and zeros are at minus a. So in all 4 alternatives this is given. 2 poles are at 0. So that means 2 branches must start from s equal to 0. So here 2 branches are starting from s equal to 0. Okay, this is okay. This is also okay. This is also okay. But here, what about this? Here pole is at, this is not correct, because 2 branches are not starting from s equal to 0. So this one is, option number C is not correct. Okay. Let us see. Now let us see alternatives A, B and D. Which one is correct? Now we can see that there are 2 poles at 0 and 1 pole at minus b. So 2 branches, one branch should terminate at open loop 0 and 2 branches must terminate at infinity. In all of 3 A, B and D, 1 branch is going to 2 branches are going to infinity. Okay, and 1 branch is terminating at open loop 0. So this is also correct for the 3 all the 3 root locus. So which one is correct? So what will be the asymptote? what will be the asymptote. So since it is given that pole is left to open loop pole minus B is left to minus A. So centroid is given by now let us try to find out centroid. Centroid is given by minus sigma A, this equal to sigma real part of poles minus sigma real part of zeros divided by n minus n. So what should be? So real part of poles are minus B 0 0 because two poles are at 0 and real part of 0 is at minus A. So minus A, okay, divided by n minus n. How many poles are there? So 3 poles are there and 1 0 is there. So it will be minus B plus A divided by 2. So it must be, the centroid must be at in left half. Centroid must lie on the real axis at left half because because B is greater than A, and this must be, and hence since B is greater than A, hence it is less than 0 because B is greater than A. Okay. So centroid must be, if we draw the root locus, then it will be like this. Here minus B, okay, here minus A, and let me write this as this point as B minus A by 2. This point as, right, B minus A by 2. This point is B minus A by 2. So, and what is the angle of centroid? What is the angle of asymptotes? Okay, and the angle of asymptotes will be angle of asymptote. The angle of asymptotes will be nothing but 180 degree multiplied by 2q plus 1 divided by n minus 1. And q will be from 0 to 1 because there are 2 open loop poles only. So this will be 180 degree multiplied by 2q plus 1 divided by 2 q from q equal to 0 to 1. So it will be nothing but one will be 90 degree and another will be 270 degree. Okay. So there will be 2 asymptote, one will be at 90 degree and another will be at, so asymptote number 1, this will be phi 1. So asymptotes is denoted by phi A. Okay. So phi 1, this will be at 90 degree. This is phi 1. Okay. At 90 degree. And another asymptote will be at 270 degree. This is another asymptote. Okay. And this is at 270 degree. Okay. And this is phi 2. So there will be 2 asymptotes and one at 90 degree and another at another phi 2 at 270 degree, and there are 2 poles at origin. Okay. So the root locus will be one part will be from here to here. Okay. This is, and another part will be like this, like this, like this. So one branch will go along asymptote number 1 and another branch will go along asymptote number 2. So which one of the given options are correct? So option number A is correct one. So option number A is correct one, because this is moving towards the asymptote b minus j by 2. Now at the last of the lecture, I would like to share one of the most important thing to you people, that if you like my video, then you must subscribe my video, so that there is no need to search out new video. Automatic update will come if I upload the new videos. What you have to do, it is very simple. There is a circular logo coming in right of me. You have to just click on that to subscribe.